Hey, good morning, everyone. Thanks for joining us again for another PSFK webinar and taking part in the sharing of this report. Today, we're going to be talking about our Future of Manufacturing report. Feel free to chat us using the chat window tool. So why don't we go ahead and get started? So our Future of Manufacturing report is the latest in what I would say would be maybe the past 18 months we've been doing a lot of digital transformation work. And I think we're starting to see the impacts of the connected technologies and data playing a huge role in disrupting entire industries. Certainly within the manufacturing realm, hopefully we'll be sharing some interesting ideas of the larger trends that we're seeing, why we think these things are taking place, how to start thinking about them within the context of your organization. So what we wanted to do was start by talking through some major shifts that we're seeing as far as how the manufacturing industry and the larger supply chain is really changing in the face of everything that's happening. So really that first major shift we're seeing is from a reactionary to a more predictive model. And really this is being driven by data and machine learning technologies within the context of all aspects of an organization. So really that notion of responding to the market either as things happen or after the fact. Really, we're starting to see that organizations and sort of manufacturing processes are now able to take all of that information and start to say, oh, we're going to see a spike happening around this time of year with this particular product. That means that we need to start to talk to our suppliers about getting specific things in our factories in order to make that happen, and then we'll be talking to our distribution partners to make that sort of delivery and distribution as quick and seamless as possible. So really being able to respond to those major shifts, not only in real time, but also moving forward. Alongside that is once you have all of that data and information that is key to making these informed decisions, really the silo can no longer, the one person owning all that information is no longer an efficient model. So instead what we're seeing is that shift from an information silo to an information network. And again, this is thinking about how you get these key pieces of information, these key insights into the hands of the right decision makers so that they can use that information as a way to make a decision again about what we're going to need from a sourcing point of view, how many people we're going to need working at a particular factory, making sure that that finished product is getting to the correct partners in the right time in the most efficient way possible. When we start to think about the production side of the business, is traditionally the factory has been set up as in a very straight line. One type of product going through from an end-to-end process, which made mass production very easy, but made customization something that was much harder to do. And so we see that shift moving from the production line to, let's call it a production ecosystem, if you will. And so really what that is enabling is a much more nimble and responsive way of thinking about manufacturing, such that a traditional sort of manufacturing process is now able to handle a variety of different products coming through, enabling that customization at a much more cost-effective and bespoke level, if you will. Along those same lines, the sort of notion that the supply chain has always been a linear process moving from supplier to the manufacturer and then end product going through to that finished warehouse or retailer, if you will. But because of all the information that's being passed back and forth, what we're now starting to see is a much more circular way of thinking about things. At any point within that supply chain, information is not only, and physical product is not only moving forward, but now that information is being fed back into the system such that it's now able to, again, feed in more of that predictive and anticipatory side of things, and smarter decisions can be made as a result of that. And then finally, while the manufacturing of products is certainly important and is not going away anytime soon, alongside that sort of notion of the product is the services that come alongside of that. And for a manufacturer, that means building, if we start to think about a product being not only the physical manifestation, but the digital model of everything that product is doing as it goes through the production side and into the marketplace, and all of the information that feeds back in. Based on that information, the manufacturer and or the service provider can start to offer things like responsive fixing of problems and other solutions built on top of that. And again, that product is then able to feed back important information back into the system, so that circular notion of manufacturing and that circular supply chain moves forward. What are the four things that we see really sort of driving the shift, these major shifts? One is the notion of the accelerated market speeds. And again, because of the rate at which change is happening in the marketplace, the competition that is happening within industries, and the expectations of consumers, now businesses, manufacturers need to be able to respond more quickly to those shifts as they're taking place, and really pushing for that constant level of innovation within the marketplace. And really that sort of drive to be maybe not always be first, but be quick to be second, is or be the first to follow, if you will, is extremely important in order for businesses to keep pace with all of the changes that are happening. The second is that there's now, particularly coming from the consumer point of view, the notion that mass-produced is no longer something that is desirable in this commoditization of product. There is now a drive and an expectation for custom and bespoke, and as a result of that, manufacturers have had to start to think about how they can enable not only that mass production at an efficient rate, but how they start to scale up the customization of products within their existing operations. Again, alongside that, and this is not just within the manufacturing space, but across all businesses today, that the notion that data is now driving the intelligence and driving the decision making that is happening is becoming more and more critical. And so to have the infrastructure in place to enable that to happen at all levels, and again ensure that that information is being fed into the right decision makers, there's the tools in place to analyze all of that information and to ensure that even as a product goes out into the marketplace, that there's still the ability to take in information about it and use that again as a smarter way of thinking about R&D going forward. And then finally, with the proliferation of e-commerce, there's a lot more pressure on the marketplace to start to think about the logistical side of getting physical products from point A to point B, and what that means in terms of doing that in an efficient manner. While the physical store still plays a critical role in that process, now businesses need to think about how that physical touch point becomes not only a place to come and buy products, but does it become a delivery node? Does it become a warehousing node? How to package products together in the most efficient way so that you're cutting down on the cost of transportation, etc. And so we'll see all these things coming through as we take you through the trends that we'll be discussing today.
And these shifts in benefits that Scott's detailed, I think they've been known for a long time, and there's definitely a pronounced need to rely on connected manufacturing, but there's definitely been a hesitancy with manufacturers to implement these processes, whether that's because of legacy systems or company culture. Not a lot of manufacturers until recently have really been taking advantage of these opportunities. But from cheaper implementation costs to much more market pressure, we're seeing this happen at a much wider scale. And for example, in the next 3 years, manufacturers are going to double the percentage of connected products that they're using. And on the other side of things, manufacturing costs are going to be reduced 10 to 20% by these advanced technologies.
And I think that alongside of that, you see the importance of the information and as it moves to the cloud, what that means in terms of that entire supply chain and keeping that connected from end to end. And there's a recognition amongst manufacturers that these solutions are going to be critical. Again, the challenge is, as Connor noted, there's a huge legacy, there's a huge existing set of infrastructure, and it's finding the right way to keep those legacy systems moving forward, but then finding a way to connect them in a way that's going to push the industry forward.
And I think also we're going to go into a couple examples that really illustrate this, but a lot of these technologies aren't just for machinery, but they also help uplift the capabilities that employees can have. So we're seeing things like IoT, connected glasses, and things and tools that employees can leverage to give them more insight into operations.
Yeah, it's true, and again, I'm sure everyone that's on has been listening to or hearing about how the shift to automation is really going to impact the human employment moving forward. I think our view is that while that certainly is the case, there's still very much a role for humans within the manufacturing process as they work hand in hand in a sort of more hybrid aspect with some of these complex pieces of machinery. There's still processes that humans can do much better than machines, but having the proper tools in place in order to ensure that works in the most efficient way possible is key to that as well. The next slide here is really providing an overview of what we're going to be taking you through in more detail today. Through the process of looking at what was happening in the marketplace, where the innovation was taking place, we identified 10 trends, if you will. And during the context of today, what we'll do is we'll talk about each of those trends and share an example of how we see that manifesting within the marketplace. But really, the sort of central arbiter of this new ecosystem, if you will, is the sort of management at the center, but how all of these systems not only work sort of in their own silo, but again communicate and share information with one another, so that everything from the information coming from the marketplace to how you're working with remote teams and partners, how that information flows into the factory floor, what that means for suppliers and distributors who are actually providing the raw materials and then getting finished product into the marketplace, and how that impacts the end customer. And in this case, we're thinking about the customer as in a B2B sense more traditionally as well. So the first bigger theme that we'll be looking at is this notion of connected product research and development. And R&D obviously is hugely critical to the lifeblood of a business, especially as, again, customers are constantly, or consumers are constantly looking for the next best product, making sure that things are super innovative and are responding to their needs in a novel way. And so what we're seeing here is that there's now the ability to take enhanced collaboration tools, better communication software, along with new tools that are able to take insights from the marketplace, communicate that back into teams, and then have them be able to use that information in a much more readily available way. Also thinking about the way that prototyping in a digital construct really enables much more rapid and iterative processes, so that once you get to that physical prototype, there's less time to get to that end product. And so to that end, the first trend that we're going to be talking about is this notion of digital prototyping, which is thinking about the way that new visualization technologies, along with virtual and digital models, are now able to really sort of take that what traditionally had been the need to create a physical prototype much earlier in the process, which could be much less efficient, could be more costly, is now allowing, at an earlier phase in that ideation process, being able to test out, simulate ideas much more rapidly, and then take those insights and use that more quickly in the R&D process, so that when you do get to that physical prototyping stage, you're much closer to that end product.
And a fantastic application of this idea is Microsoft's mixed reality goggles, HoloLens. And they're partnering with several different manufacturing companies, but one of these partnerships is between Trimble, which is a architectural workflow collaboration platform, and the University of Cambridge. And what they're doing is allowing architects and engineers to see the blueprints that they've created digitally in the real space. And typically, when you're doing a digital blueprint, you can't connect it to, it's a siloed process, and you can't bring that into the physical space. But what this is doing is really speeding up the process and not only making it more efficient, but making it less error prone, because you don't have to go between paperwork or site visitations, and you can do it all in the digital space. And we actually have a video that illustrates that a little more closely.
The biggest problem we have in exploiting digital information of infrastructure is how we interact with it, both on site and in the office, in order to make engineering decisions. We've never been able to bring 3D models of buildings and bridges off our screens and onto the real structure, or in full scale into our working environment. Here at the University of Cambridge, the Construction IT Lab is conducting research on improving design, construction, and operation workflows by introducing new automations and technologies that can leverage the digital world.
Using mixed reality, we are now able to bring a copy of the physical asset into our office. This copy is fully textured, data-rich, and an exact replica that can be used, for example, for condition assessment. Inspectors can use this to find problems and assess their impact on the structure. This way, they do not have to close bridges for a while, to go on site and expose themselves to health and safety risks.
Beyond that, mixed reality also allows us to bring the design information to the construction site. Matching the 3D design model with the real building under construction allows us, for example, to automate progress monitoring by simply walking around the site. Inspectors can use this to automatically check the construction progress, identify problems, and take timely corrective actions. This way, we can prevent time and cost overruns during the construction phase.
I like that little personal note at the end there. And I think what we're seeing alongside of that is, again, whether you're making a product or making a physical structure or what have you, and the realities of today's world is that you have multiple partners that you're working with, both within the context of an internal team as well as external partners that all need to be weighing in on these processes. And so alongside of that, we see that these cloud-connected platforms now are enabling people working, engineers, developers, etc., to take feedback from external partners, from the marketplace, and really push that into their design process much more easily and readily, so that when you're actually bringing a product to the marketplace, it's as up to date and refined as possible and meets the demands that the marketplace expects from it.
And Inditex is a Spanish clothing retailer that owns Zara. And I'm not sure if you've been into Zara, they actually don't have a huge amount of inventory, but they are constantly updating it. And every time you go in there, they have a new line of clothes, and that's because they only produce about 15% of their future garment manufacturing. So while they're designing these garments, they'll wait to look at customer demand and consolidate that, and also look to specific customer feedback or feedback from managers or other international teams, and use that to implement into the manufacturing process.
I think what's really impressive about the way their organization functions, and I think they're very much the leaders in this sort of fast fashion space, if you will. They have created at their headquarters essentially a sort of data HQ where there's literally people sitting in front of monitors, taking in all of this information, and then they're thinking about how to distribute all of the insights pulled from that to different aspects of their organization. Certainly within the fashion space in particular, there's a number of companies now that are starting to think in that same way. We've seen sort of traditionally, the idea of seasons moving away and much more thinking about sort of pushing products in as it's ready, making that available to consumers as you see it sort of walk down the catwalk, if you will. There's a lot of challenges to making this an efficient model, but seemingly within the way that Inditex has been sort of thinking about this, they've been quite successful in terms of, again, thinking about all the different touch points within that process and how to get data and then turn that into insights, which then influences their decision making as an organization.
And it also lowers the opportunity cost of, say, an experimental or innovative product line, because in case there is an issue, an unexpected issue, there's less of they don't lose as much sales or you lose as much money in case there is an unexpected issue, because they only produce a limited amount of said item.
So as we close out that first section, we'll just look at a couple of things that what this means in terms of next steps from both a business decision maker standpoint and an IT standpoint. Again, thinking about how real-time knowledge sharing platforms, how you implement those within the context of an organization. Can there be an opportunity to have feedback being delivered at a store level and taking that up to, again, that sort of HQ point of view. Thinking about how products are designed based on those market insights, where that's in that sort of development process, it's important to bring them in. What's necessary in order to make that happen. And then thinking about, again, how collaboration plays a role, of course, across the whole product development process. And from an IT perspective, again, what are the sort of tools that you need to sort of make that happen? Certainly machine learning at a very sophisticated level in order to take unstructured data and pull insights from it, being able to understand, what are the key questions that you want to ask, what's the right data that's necessary in order to make that happen, and how that translates into the organization. And then how you truly sort of enable that monitoring to happen at any given level. So as we move into the next section, it's really sort of thinking about the sort of level of agile production that can begin to happen when connected and sort of intelligent equipment and manufacturing machinery begins to become a key aspect of that production line again. And this is really, again, sort of thinking about how you marry the notion of mass production with the notion of mass customization, enable that to happen at the most efficient way possible, so that you have all of the right components on hand in terms of raw materials and are able to sort of translate that into the best end product possible. So I think the idea of customization has certainly been around for a very long time. At the very, pre-industrial, that was all happening at a sort of personal and bespoke level. And then within the past, let's say 15 to 20 years, with sort of digital beginning to play a role in that, we started to see that happening at a very sort of bespoke level. The notion of like a Nike ID comes to mind here, where you're able to customize specific aspects of a product, and then it goes to a custom manufacturing facility where it's produced as a one-off, and generally there's a lag of several weeks to months to actually get that into the hands of the consumer. And there's a lot of there's a lot of lag time. There's a lot of inefficiencies in that process to produce a one-off. Now what we're really starting to see is, with new manufacturing equipment happening, that the ability to produce one-off products is now able to happen much more cost-effectively and much more rapidly than was previously available. And those cost savings not only impact the manufacturer, but can be passed on to the end consumer, so that it's a much more attractive proposition for them to get something that feels personalized to them.
And I think a really common application that a lot of retailers are using are 3D knitting machines. And the Ministry of Supply is a retailer, Boston-based retailer, that actually put a 3D printing machine in their stores, and customers can order a bespoke sweater, and they can customize the color of the body, the cuffs, the buttons, and even once it's finished, it's washed and dried, so it's pre-shrunk, and this all happens in 90 minutes. And I think something with this report that we were trying to illustrate was this idea that connected manufacturing isn't just for behind the scenes, just for the manufacturers, but it also really engages customers. And we're going to go into examples later that illustrate how customization occurs behind the scenes and within the manufacturing plant, but this is a really great example of something that's at the front line of customer service. So while it on the retail side of things for the customer makes the process more experiential, but for Ministry of Supply they don't have to worry about transporting these sweaters because they're made in-house. So it also offers them that opportunity.
Great. And then thinking alongside what Connor just mentioned, obviously looking that first example was really sort of thinking about a much more bespoke experiential process that engages the consumer. And certainly if you bring to bear a number of those knitting machines in one place, it certainly changes again that manufacturing process at scale. But now we're sort of looking at what this means from a much more sort of traditional production line point of view. And really what we're seeing again is this really taps into that notion of moving from a production line to a production ecosystem or thinking about the sort of notion of a production module, if you will, where the manufacturing equipment is less rigid, is more flexible, and is able to begin to offer a different level of customization. And alongside this really, again, sort of taps into that notion of what a smart product is or a connected product is. And I think traditionally we think about that from the standpoint of a connected product which is going to an end consumer. But within the manufacturing space, that really starts at that sort of that initial level, so that you have a digital mirror of that product existing as it moves down the production line, such that it contains all the necessary information about what level of customization is required, and that communicates directly to the machinery such that it begins to influence the way that it's actually being constructed.
And a great application of this is Fraunhofer Institute for Production Technology. They created a production system in which every manufacturing workpiece is connected to a central hub. And this central hub contains the instructions for every for the best next steps to take to create the item. But what's interesting about this network is that each machinery is given the agency to choose the best next step to take. And I think the best way to illustrate this is to think about a car GPS system and how it provides the best routes based on real-time data. So in the production line, this machinery chooses what next steps to take and whether it wants to do this on its own or outsource it to another workpiece. And this eliminates unexpected downtime. If a machinery can do it itself, then it can. And this, again, also it enables it to accompany specific customer requests that deviate from the status quo as well.
Yeah, and I think what's interesting is, and you can see this illustrated within the context of this image as well, is, while there's a certain level of agencies that is being outsourced to the individual pieces of equipment, there is that sort of central control panel that, the factory manager or the production, an individual working on that production line has and is able to sort of control things in a much more visual sense, and has that sort of overview and the ability to sort of step in and take over as necessary as well. So a couple things to consider here from, again, a business point of view. More and more we're seeing this now, how the customer is being invited into that creation process. That builds brand equity and develops those deeper relationships. And once you start to enable the customization of products at a mass level, what's interesting about that is you can start to take the data that's being driven by that and see where trends might be happening. Again, sort of taking those insights and saying, oh, it looks like a specific color or a specific material is becoming quite popular. Do we need to think about sourcing that, getting in touch with our manufacturers down the road in order to make that, have that readily available? Can we think about taking those insights and translating that into a line of mass-produced products? And then, again, when a product is moving through that manufacturing process, it creates an opportunity to connect with the customer and show them, have those conversations with them earlier in the process, and being very transparent about how that's all taking place. And then, again, sort of from an IT point of view, thinking about how all of this machinery is operating, how it's collecting data, and again, sort of feeding that back into the organization at a deeper level. We'll talk a little bit later about how that information at an individual sort of equipment point of view can predict when potential malfunctions are going to happen and catch that earlier in the process. And then, again, sort of thinking about how that information impacts production schedules, inventory, and how that impacts the logistical side of the business as well, both from a supply and a distribution point of view. Again, we'll start. We looked at the sort of manufacturing process from the standpoint of customization, but now what does that actually mean from a sort of data-driven point of view, and what does that mean for creating new efficiencies within the marketplace, ensuring that there's the safe and continuous operation of equipment and individuals within the factory, ensuring that, again, we're thinking about this from the standpoint of an ecosystem so that you can not only impact and improve the daily operations, but use that information as a way to predict and anticipate future demands and the future sort of operational constraints of a factory as well. So along those lines, the first trend that we'll talk about here is what we're calling responsive optimization. And this is really thinking about once the factory floor is connected both from sensor-enabled equipment, we're also seeing smart cameras playing a role within this space as well, heat mapping technology, etc., that this information can be collected, analyzed, and uploaded to a central database or dashboard, enabling decision makers within that process to really sort of make adjustments on the fly. Again, whether that's taking a piece of equipment offline so that it can be serviced, or thinking about the need to switch up human scheduling of factory workers to ramping up production to meet the needs of the marketplace.
And so Lighthouse is an app that provides employees with context-specific information about task lists that they need to conduct, or safety information or key instructions. And how this works is a manufacturing plant equips its production line with various Bluetooth beacons that provide signals to the app that these employees have. And I think this really illustrates that idea that you can make these changes, you can empower the employees to make these changes or adapt to changing circumstances in real time. And it gives them also, it clues them into to a dashboard that their boss has that can give them more concise information about what is happening in real time, what is happening with the plant that they need to fix, and how operations can be conducted more smoothly.
And then again, thinking about not only the sort of real-time notion of information and using that to impact decision makings, but how you can preemptively use that as a way to troubleshoot issues before they arise. The ability taking a piece of equipment offline for 1 to 2 hours for regular servicing versus having it break down completely and having to take it offline for a week is a much different equation. So how you take that notion of analytics and performance data and use that to more smartly make decisions about the running of that production line.
And a common problem that we've seen manufacturers run into is they have so much data, and data mining is very accessible for them, but how do you sift through that, and how do you make something actionable and insightful from these mass troves of data? And Data RPM is a software that manufacturers can use to help them create models based on their performance data, and these models help them predict when maintenance is going to occur, predict when downtime may occur, so that they can sort of compensate and make production overall more smoothly. And Data RPM was recently acquired by a provider of cloud-based tools called Progress Software Corporation. And so the idea here is that manufacturers can create their own software tailored to their own needs and still create these predictive models, but have it tailored a little bit more to their specific production needs.
So a couple things to keep in mind here is thinking about as you're sort of doing that sort of larger level of planning, thinking about how you bring contextual factors to bear as part of that demand planning. Do things like weather, specific things that are happening in a particular region. How does that all impact what potentially demand will be, such that you can use that as a way to better plan from both a production need as well as from a sort of raw materials and resourcing need, ensuring that that you're thinking in terms of infrastructure and technology that is that's flexible, able to be updated and adapted, rather much more from a sort of software point of view rather than a hardware point of view today. And then thinking about how you take those, take insights from data and use that as a way to identify operational inefficiencies and have the structures and processes in place that you can then quickly move to remedy those situations. It's interesting to see the role that VR and AR, again, I think, one of the things that we see is that while it's been slower to sort of find killer use cases within the sort of consumer marketplace, there's a lot of really interesting ways that VR and AR technology have applications within the sort of B2B space. Specifically, when you start to see the layering of information on top of the physical world and how that enables humans to diagnose problems more efficiently, fix those problems as well. Having a level of AI assistant on hand to, again, sort of act as an intermediary to take on some of that information as it's coming in, and use that to sort of automate operational decision making, not at a sort of hugely, not maybe making wholesale changes, but making refinements at a much more real-time manner is quite interesting. And then again, thinking of what the actual technologies are that you need to have in place from a sensor and or connected camera point of view to really get the biggest picture of what's happening on an operational side in order to enable that to happen. The next idea that we're going to talk about here is thinking about how transparency plays a role within that sort of manufacturing journey. Again, sort of thinking from the standpoint of supply chain and transparent in the sense of having information readily available to all parties as they need it, so that they're able to work together much more efficiently to meet the changing demands of the marketplace, of individual partners. If a shipment is delayed, how do you make sure that you're able to step in and find new suppliers or partners to provide the raw materials or get that to, again, the end consumer, and really sort of constantly changing and updating to meet those demands. So the next idea we're going to talk about is what we're calling dynamic logistics. And this is really, again, sort of thinking about how you understand where a physical good is at any point within that process. And that could be very early in the supply chain, all the way through to understanding where a product is on the manufacturing line, in a warehouse, or en route to its final destination. And taking that information and using that to make smarter decisions and be more efficient about how things move from point A to point B.
And in considering the supply chain, I think it's important too to note that it doesn't just go one way; it also can come back. So, say a consumer doesn't like their purchase, they return it, and that can often create a lot of friction for a retailer's own internal operations when trying to add back this product back into their warehouses. But Zigzag helps them direct these return goods to nearby warehouses, so they don't have to deal with the costs or friction associated with returning goods back to their manufacturing origin. And so Zigzag not only provides them a space for them to hold the good, but it also helps them resell the good, and they'll share the profit with both the retailer and the consumer.
And then the next notion is, again, thinking about the notion of the transparent supply chain, and really starting to think about how, again, that information is made readily available to not only consumers, but to all partners within that process. What we're really seeing here is technologies like RFID, and more recently the notion of the blockchain coming to bear, such that at any given time you can understand in a sort of authenticated way the condition of a particular product, understand where it's been, where it's come from, at all points through that particular journey.
And Walmart started using blockchain to track how pork moves through commercial networks. And I think this is especially important for both Walmart and consumers, because they can verify that the pork is clean and edible by seeing how it moves from producers to processors to distributors to grocers. And this list of transactions is very, very available, and if there is some kind of discrepancy, they can access the specific pork and remove it from the supply chain.
Yeah, and I think that's the sort of huge sort of shift from a business point of view is traditionally when there's been an issue with tainted meats or other food products, the sort of traditional response has been to have to pull all the particular products out of the marketplace to ensure safety. Now there's a much you can pinpoint that in a much more accurate manner in order to enable that to happen more efficiently, identify where the problem is, and then remedy that situation much more quickly. So it brings a lot more intelligence to that process. And again, with the blockchain, the thing that makes it such a powerful piece of technology is that it's creating a secure account that can't be meddled with, that's tracking every point in that sort of transaction process, if you will. And that ledger is hugely important in terms of again, sort of having the understanding where the breakdown occurred and then responding in kind. So a couple things to think about here. Again, using RFID to track a product's location throughout the supply chain. Again, partnering that with technologies like the blockchain starts to really sort of change the knowledge and understanding from an end-to-end point of view. Beginning to think about, and this is, I think very much been the case, but the diversification of supply chain partners. And I think what we're seeing is with the way that delivery and distribution is happening now, it's much easier, particularly from that sort of distribution point of view, to be more nimble on that aspect of the supply chain. And then thinking about the role that prototypes and simulations can play within that process. And from an IT point of view, using blockchain as a sort of key point within that sort of manufacturing journey, and thinking about how, again, as Connor mentioned, we think about this less in a linear point of view, but more in a cyclical point of view, so that information is constantly being fed back into key decision makers so that they can respond in kind to that information. The final section that we're going to talk about today is again thinking about the sort of continuous operation of equipment and sort of end products within the marketplace, so that again you're able to take preemptive actions in order to make the process much more efficient. And this is thinking from an end point of view again, and this is that notion of adding a layer of service on top of an end product. So really starting to understand where breakdowns might occur, stepping in early in the process so that the downtime is kept to a minimum. Safety is obviously at the forefront here, and how you begin to sort of communicate the notion of how field work and service operations becoming a critical part of that process as well. The notion of onboard collaboration is quite interesting here from the standpoint of, again, thinking about how you bring to bear advice, communication, and collaboration to a remote field worker, and the expertise necessary so that the person that is in the field has all of the information that they need, can tap into, whether it's an OEM to get information about a particular piece of equipment, and or has constant contact with the person back at their HQ who is moving them through during their day as well.
And I think this idea is really interesting when you think about the limitations that are normally associated with services. So back to that idea of that Scott was saying about extending, turning products into services. I think this idea of onboard collaboration and uninhibited services is really illustrated when you think about sending people out into the field and equipping them with the means to perform maintenance duties. So you're not limited by having the customer come back to the manufacturer, and they can really stay fluid and stay where they're at. But with the DAQRI smart glasses, this is another smart glasses illustration, but it's a bit different from what Microsoft was doing. And these are AR glasses that allow coworkers to share visual points of view with one another, and these can connect back to either different glasses or connect back to a desktop computer and give field associates informed points of view about instructions or simply just safety needs as well.
And then finally, this notion of predictive analytics, which again not only impacts the sort of servicing of end products, but has a role within the broader, at every point within that manufacturing process, which is taking all of the information that's coming from the marketplace, external contexts, etc., to really sort of start to think about what that means from a resourcing point of view, from, again, thinking about the necessity of supply chain, what that means from a factory point of view, all the way through to what that means in terms of distribution as well.
So JFK started using a software called Bayonetra, which basically aggregates, compiles, and makes very accessible passenger volume, how long it takes people to get inside the airport, all of these contributing factors that we think of when we start planning how far in advance to get to the airport. But what Bayonetra does is make this very accessible for whether it's TSA agents, immigration officers, or airlines, and they're able to staff appropriately and forecast how much staff is going to be needed.
And again, I think from a sort of customer experience point of view, as well as from a business efficiency point of view, this is hugely important in terms of thinking about making sure that you have the right people deployed at the right times, and then during down times or low volume times, it's less critical, and you can save on having less staff available. And certainly that same notion of using data in a predictive perspective plays a role within other aspects of the manufacturing journey as well. So finally, how does this manifest from a business point of view? Again, thinking about how you're thinking about the end product within the marketplace, and if you're tracking usage rates of a product like an elevator, let's say, can you use that to pinpoint potential impacts earlier on in the process and be more predictive or anticipate potential shifts before they occur? We're moving into a sort of moment where, again, while there's still physical moving parts, software-based updates are a huge part of that connected end product as well. So how do those play a role within making sure that an end product is operating at its most efficient at any given point in time? very early days of that happening within the automotive space, but I think that's a great metaphor for what we're talking about here. And then again, using, understanding sort of traditional patterns of servicing across all of the products that are out there to ensure that you're deploying maintenance workers in a much more efficient manner. From an IT point of view, how do you better equip your offsite workers to do their jobs much more efficiently? Is that visual technologies like VR, AR, or is it sort of real-time, hands-free communication technologies? How sensors equipped within that sort of end product point of view push information back to HQ so that you can make, again, smarter decisions about maintenance and repair. And again, talking about that notion of maintenance based on usage patterns as well. So as we close off, just 4 larger technologies that we really see having a huge role going forward within the manufacturing space. First, the notion of cloud connectivity and IoT technologies, really working in concert with one another to not only capture the information but push that up into the cloud where it can then get communicated to the proper parties. The notion of big data analytics and machine learning in some ways going hand in hand with one another, but both from an analytics point of view, thinking about how you're taking all this unstructured data, using that to inform decision making and getting that in the hands of the right individuals who can then act on that. Machine learning, let's think about that more from the perspective of AI, how this impacts the ability to automate and offload certain tasks. We saw that as, again, we're not sort of fully talking about automation at this point, but constantly being able to refine and make changes based on the information that's coming in, and to play a helpful role within that human, with the human factory worker, the human end user, and how that impacts their day-to-day jobs. And then from a sort of internal team perspective, as well as across necessary partners, how real-time communication platforms play a huge role, again, in making sure that everybody is getting on the same page, sharing information seamlessly, and then working together to create the best outcome. So I want to thank you for joining us today. The entire report is available for free to download through PSFK. We shared very much a snapshot of that report today. If you download that full report, we have 5 very detailed scenarios that show how all these trends work together in future-forward contexts to really impact various roles within that sort of supply chain, again, at the factory floor, within the sort of field worker point of view, how that impacts distribution and the sourcing of raw materials. We've got a bunch of expert insights within that. We've got additional case studies, and then a number of additional takeaways and things that you can use within your particular role. So thank you again. Hope you guys found this useful. We can take a moment and let anyone step in and ask questions. Otherwise, I believe you have Jeff's contact information. If you have additional follow-up, you can also email him as well.